So today, we're simplifying square roots. In math, sometimes we have to multiply a number times itself. Happens pretty often. And sometimes we have to go backwards. A square root is the number that when you multiply it times itself, you get the original number. Now, some square roots work out nicely, and you've known them for a long, long time. But when the radicand is something that doesn't square root nicely, that's when we've got some work. There's still a square root. It's just not a nice, pretty integer anymore. We can estimate the value of that square root. If you've got really strong numeracy, then you can do it by finding the perfect squares that are adjacent to that number, taking their square roots, and then finding the number that's approximately in that area. But a better way is to let your technology do it. But there's a problem. This is only an estimate. Even if your calculator shows a whole lot of digits, any non-pretty square root has an infinite number of digits. Your calculator is only showing you a few of them. Now in math, we like things simple. With a square root, anything held hostage under the radical is not simple. So if you're asked to simplify a square root, your job is to liberate as many of these hostages from under that radical as you can. And there's a process. Factor the radicand. Find two things that multiply to make your number, where one of them will square root nicely, preferably the biggest one. Split your radical into those two factors, each of which will live under their own radical. Then, square root anything you can. That's 16 square roots to make 4. This is still the square root of 5. Careful, when you do this square root, you don't need the square root symbol anymore. If you take the square root of 16, it's 4, not the square root of 4. And note, when you write a term with a radical in it, write the radical last. That keeps us from accidentally sliding anything underneath the radical symbol that doesn't belong there. So this one would become 4 square roots of 5. Believe it or not, these really are the very same thing, but this one is simpler. Now you can split up anything under the radical as long as the resulting pieces stay underneath their own radicals. You can also multiply back together, and it even works for dividing. And once you've changed that radical by splitting it up, by multiplying it up, by dividing it, if you can find something that square roots nicely, go for it. Liberate those hostages. Finally, since we're going for simple, mathematicians hate having a radical in the denominator of a fraction. It has to do with how impossible it would be to divide by a number that goes on forever. We fix this by rationalizing the denominator, which means multiply the fraction by the radical in the denominator over the radical in the denominator. You're not changing the original number because anything over itself is just 1. You're only multiplying this fraction by 1, which doesn't change it, but it will simplify it. The radical on bottom times the radical on bottom kills the radical on the bottom. And after multiplying out the top, you'll be left with an equivalent value, but simpler, at least as far as mathematicians are concerned. So you want to see it a couple more times? Let's go. Simplify the square root of 18. I'm going to break that into the square root of 2 and the square root of 9. I know those two factors are going to work out well because the square root of 9 square roots easily. I get the square root of 2 times 3, which I'll rewrite as 3 square roots of 2. Try it again with 60. There's several factors of 60. There's 2 and 30. Neither of those are any good. There's 4 and 15. Square root of 4 times the square root of 15. The square root of 4 square roots nicely. I'll get 2 square roots of 15. Done. Find some radicals that are multiplied or divided, then go ahead and combine them. Perfectly legal. You may not immediately recognize the square root of 3 times the square root of 27 is really the square root of 81. Oh, we know what the square root of 81 is. That was easy. The square root of 48 over the square root of 2. May look ugly at first, but you know 48 divided by 2 is 24, right? So let's turn this into a single radical. And I can factor this. I can make it the square root of 4 times the square root of 6. 6 doesn't square root nicely, but 4 does, making this 2 times the square root of 6. Finally, here's a fraction with a radical in the denominator. That'll never do. So let's kill it. I'm going to rationalize the denominator by multiplying this times the square root of 2 over the square root of 2. I use the one on the bottom because that's what I want to kill. Multiply straight across. 4 times the square root of 7 times the square root of 2 makes 4 times the square root of 14. The square root of 7 times the square root of 2 can multiply together. Put that over the square root of 2 times the square root of 2, making 2. I can go one step further now, can't I? The 4 and the 2 are not under radicals, so I can make them as small as I want. Take the 4 and the 2 and cancel, and I wind up with 2 square roots of 14 over 1, or simply 2 square roots of 14. Now if you're thinking, some of those answers don't look any simpler at the end than they did to start with. Well, then you're thinking that simpler means prettier or more organized. To mathematicians, simpler means easier to math with later. Now you know how to simplify square roots?
Don't be afraid of your freedom. 'Cause I'm free.